Have you ever heard someone say, the polar vortex is coming, on the news or from a friend, and suddenly everyone is talking about it? And then, almost overnight, it feels like the temperature outside has dropped to bone-chilling levels? The term polar vortex might sound like something out of a science fiction movie, but it's actually a real and fascinating part of our planet's atmosphere. So, what exactly is the polar vortex, and why does it matter to us? Imagine a gigantic, spinning pool of icy air that sits high above both the North and South poles, swirling around like a frozen hurricane. This atmospheric fence is made up of powerful, west-to-east winds that act like a barrier, trapping the coldest air on Earth close to the poles and keeping it from spilling south. The polar vortex is strongest during the winter months, fueled by the dramatic temperature difference between the warm equator and the freezing polar regions. Unlike a storm or a tornado, the polar vortex isn't a one-time event. It's a massive, persistent wind pattern that's always present in the upper atmosphere, usually stable and contained. When you hear about the polar vortex in the news, it's because a part of this wind barrier has weakened or broken off, allowing that frigid polar air to escape and surge southward into areas that are usually much warmer. It's actually the breakdown or disruption of the vortex that leads to wild, unpredictable winter weather, not the vortex itself. Most of the time, the door to the Arctic stays firmly shut, but every so often it swings wide open, sending a blast of Arctic air our way and causing those sudden, extreme cold snaps. By understanding how the polar vortex works, we can better explain and even predict some of the most extreme and memorable winter weather events that we experience, helping us prepare for whatever Mother Nature throws our way. Let's dig deeper into one of the most fascinating forces shaping our winter weather, the polar vortex. Picture a figure skater spinning on the ice, arms pulled in tight, spinning faster and faster as they draw themselves inward. That's a lot like what happens with the polar vortex in winter. A swirling mass of cold air high above the Arctic, spinning rapidly. During winter, the North Pole tilts away from the sun, plunging the region into darkness and creating a huge temperature difference between the Arctic and the milder south. This sharp contrast in temperature powers the vortex, making it strong, stable, and able to trap cold air in the far north. Fast-moving winds whip around the Arctic, forming a kind of invisible barrier that keeps the frigid air locked in place, away from lower latitudes. As long as the vortex remains strong, the cold air stays put, and winters in much of the northern hemisphere are normal, cold, but not unusually harsh. The polar vortex is a seasonal phenomenon. It forms in the fall, reaches its peak strength in the heart of winter, and then gradually weakens as spring approaches and sunlight returns to the Arctic. As the sun rises higher and warms the pole, the temperature difference shrinks, the vortex slows down, and eventually fades away until the next cold season. When the vortex is strong, it acts like a lid, containing the cold air and keeping it bottled up in the Arctic. But when the vortex weakens, the jet stream can become wavy and unstable, allowing cold air to spill southward. That's when the spinning top starts to wobble, and our weather can suddenly turn wild and unpredictable. The polar vortex is a crucial part of Earth's climate engine, influencing weather patterns across the globe. Its strength and stability shape our winters, determining whether we get mild chills or bone-chilling cold snaps. When the vortex falters, the real drama begins, ushering in powerful winter storms, deep freezes, and wild swings in temperature that can affect millions. What does it mean for the polar vortex to collapse? It doesn't vanish, but it gets distorted or splits apart. Imagine nudging a spinning top. It wobbles and slows. In the atmosphere, this nudge comes from powerful waves rising up from below. These waves, often generated by mountains or temperature contrasts, can disrupt the vortex, causing sudden stratospheric warming, sometimes by 50 degrees Celsius in days. The warming erases the temperature difference, the vortex weakens, and its winds lose structure. Instead of a tight circle, it stretches or splits into smaller vortices that wander away from the pole. This chain reaction shows how events near Earth's surface can shake up the atmosphere 30 miles above, Polar vortex collapses aren't common, but when they happen, the effects reach all the way to the ground. That wobble up high is about to send a cold message down to us. When the polar vortex breaks down, the effects cascade downward, disrupting the jet stream, the fast-moving river of air that steers our weather. Normally, the jet stream keeps cold and warm air separated, but a weakened vortex makes the jet stream wavy, with deep dips and high ridges. These dips let Arctic air spill south, bringing frigid temperatures to places that are usually milder. Meanwhile, ridges pull warm air north, creating bizarre weather patterns. Deep freezes in one region, unusual warmth in another. A polar vortex event doesn't make the whole world colder. It just shuffles the deck, rearranging cold and warm air. The process takes a week or two to reach the surface, giving forecasters a window to predict major cold snaps. Monitoring the polar vortex is a powerful forecasting tool. It's a dramatic example of how interconnected our atmosphere really is. So, what does this mean for you? A weakened polar vortex can turn winter upside down. In North America, a disrupted vortex lets Arctic air plunge south, bringing deep freezes to cities like Chicago and New York. These cold snaps can be extreme. Wind chills drop, power grids strain, schools close, and pipes freeze. Lake effect snow can pile up as cold air sweeps over the Great Lakes. In Europe, a vortex collapse can trigger the beast from the east, sending Siberian air westward and bringing heavy snow and paralyzing cold. Even cities like London or Rome can see rare snow and freezing temperatures. These events disrupt transportation, test energy supplies, and pose risks to public health. The polar vortex is a global player. Its moves are felt thousands of miles away. It's a reminder that we're all connected by the atmosphere. Throughout history, countless winters have been shaped and defined by the powerful influence of the polar vortex. This swirling mass of cold air, high above the Arctic, has unleashed some of the most memorable and severe cold snaps ever recorded, leaving a lasting mark on communities and weather records alike. Take 2014, for example. That year, a dramatic stratospheric warming event weakened the polar vortex, allowing frigid Arctic air to spill far south into the United States. Even typically warm states like Florida experienced rare freezing temperatures, shocking residents and disrupting daily life across the country. Just a few years later, in 2019, another major collapse of the vortex brought record-shattering cold to the Midwest. Wind chills plummeted below 50 degrees Celsius, creating dangerous conditions and forcing people to take extraordinary precautions to stay safe. The cold was so intense that the U.S. Postal Service made the rare decision to suspend mail delivery in several states, a testament to the storm's severity and the risks posed by such extreme weather. Across the Atlantic, Europe faced its own polar vortex drama in 2018, known as the Beast from the East. Once again, a sudden stratospheric warming event disrupted the jet stream, allowing icy Siberian air to sweep across the continent and plunge millions into an unexpected deep freeze. Cities like London and Rome, unaccustomed to heavy snowfall, were blanketed in white. The rare snow led to widespread travel chaos, school closures, and scenes of daily life brought to a standstill. But these dramatic events aren't just a modern phenomenon. Historical records and ancient manuscripts reveal that similar cold snaps have occurred for centuries, especially during periods like the Little Ice Age, when polar vortex disruptions may have been even more frequent. By studying these past events, scientists gain valuable insights that help them build more accurate weather models and improve our ability to forecast future cold outbreaks. Each polar vortex-driven cold snap acts as a real-world experiment, offering new data and opportunities to deepen our understanding of atmospheric science. The lessons we learn from the past help us prepare for the winters yet to come, reminding us that history is a powerful teacher when it comes to extreme weather. The polar vortex remains a key player in the ongoing story of our planet's weather, shaping both history and the future of our winters. What triggers a polar vortex collapse? The immediate cause is sudden stratospheric warming, driven by powerful atmospheric waves from below. But are these events becoming more common, and is climate change involved? The Arctic is warming twice as fast as the rest of the planet, reducing the temperature difference that powers the vortex. Some scientists think this weaker gradient makes the jet stream wavier and the vortex more vulnerable to disruption. Heavy Siberian snow cover may also play a role, creating cold air masses that help generate the waves that disturb the vortex. The science is complex and evolving, but it's clear that changes in the Arctic are affecting the whole system. We're still piecing together the puzzle. It seems odd. Global warming, yet more Arctic cold outbreaks. How can both be true? The leading idea. A rapidly warming Arctic weakens the polar vortex, making it more likely to spill cold air south. A weaker temperature gradient means a wavier jet stream, which can trigger sudden stratospheric warming. Some studies show a strong link between Arctic warming and vortex disruptions. Others say it's still within natural variability. Science is about debate and discovery, but one thing's clear. Climate change is making weather more unpredictable. Understanding the polar vortex is crucial as we face a future of more weather whiplash. Changing the planet's energy balance has real consequences. Why care about the polar vortex? Because it shows how connected our world is. What happens above the Arctic can freeze your pipes or close your school. Better forecasting gives us time to prepare. Cities can ready snowplows, power companies can brace for demand, and we can protect our homes. Studying the vortex also helps us understand climate change and its ripple effects. It's a powerful lesson in cause and effect on a planetary scale. The polar vortex is a giant, invisible weather engine that shapes our lives. Curiosity about these systems is what science is all about. Next time you hear polar vortex, you'll know the science and the story behind the cold.